Good day, Professor. Today I will present a simple program about the safety of enumeration types or simply enums in C++ and C#. So this is my laboratory exercise 005, comparison of two programming languages using enumeration types as part of the theory of programming languages. So the procedure is: write a simple program in C++ to investigate the safety of its enumeration types. Include at least 10 different operations on enumeration types to determine what incorrect or just silly things are legal. Also, I will write a C# program that does the same things and run in to determine how many of the incorrect or silly things are legal. So in this video, I will answer the questions: what is the output of your program, and compare my results, both C++ and C#, and discuss some of the source code. Okay, so what is an enum? Enum short for enumeration, right? So it is a data that lets us store a fixed set of name values. So example, a color. So color can be a red, a green, or a blue. So again, an enum or enumeration, it is a data that lets us store fixed set of name values. Example, as I said, like a color: red, green, and blue. So enums help make programs easier to read and organize. However, some programming languages still allow incorrect or silly operations on enums, such as assigning invalid numbers or treating them like a normal integers. So in my activity, I will create a simple program in C++ as well as in C# to investigate the safety of its enumeration. So in my activity, I will create two programs. Both programs test several enum operations, such as printing enum values, comparing enum values, assigning new values, converting integer to enums. Because in this activity, I will create at least 10 different operations on enumeration types. So in converting integer to enum, performing arithmetic operations using switch statements, checking whether a value is valid. So we have now 7 and so on. Okay, so these are my goal to create these tests for enum operations. So the purpose of this activity is to see how safe enums are both in languages C++ and C#, and to compare which language is stricter. So okay, maybe I will start with the C++ first. Okay, so I will go to this online compiler. I will create from the start. Okay, so this is the C++. So we always start with this one. So include IO stream. Next is using namespace std. Okay, so in enumeration, in my example here, we will create a color. So I will type here enum color, open and close curly bracket, a red, a green, and a blue, semicolon. So this one is, this creates I will type the this creates an enum named color, and also the values are red. So in programming, we always count from starting with a 0. So 0, green is 1, and blue is equal to 2. Okay, let's try this one out. Oh, sorry, this one is a comment. This one is a comment. Let's try again. Okay, so enum color red, green, and blue. So let's try now all the possible tests for enum safety. So integer main, open and close parentheses, open and close curly bracket. So in number 1, I will add here color C is equals to red. Okay, so number 1 is printing enum values. So I will just print an enum values. So 1, print enum value. So in C++, enum values are usually shown as their integer. Value. Okay, let's add the code here. So number 1, I will print an enum value. So the code here is character output 1 value of C, comma, character output value of C, the C which is red, and line. Okay, let's start. Okay, so number 1, value of C is equal to 0. Why 0? Because the value of C is red, which is red is 0. Okay, so again, in C++, enum values are usually shown as their integer value, which is the integer value of red is 0. Okay, number 2. What's my number 2 here? I'll just complete some of the numbers here, 8, 9, 10, if after this one. Number 2. So in number 2, comparing enum values. So number 2 is to compare enum values. So this one checks if C is equal to red. Okay. If C is equal to red, then C out or character output to that C is red. Okay, and line. Okay, let's try to run this program. Okay, C is red. Okay, so if C is equals to red, so number 2, we will just compare enum values. Number 3, what's my number 3? Assigning new values. So number 3, I will assign another enum values. So now we change C from red to green. Okay, red to green. Number 3, C is equals to green, semicolon, character output 3, C change to what? To red. Green. C and line. Let's try again. So C changed to 1. Why 1? 1 is equivalent to the green here in this part of the code. Okay, so we have now 3 examples or safety lists for enums. We have here the print enum values, comparing enum values, as well as assigning new values. Number 4. So in my number 4 here is converting integer to enum. Okay, let's start with this one. So my number 4 is cast integer to enum. So this one is, this changes integer 2 into a color value. What else can we add here? Since blue is value 2, C becomes blue. Okay, let's add the program. C is equals to color 2, C out character output for assign integer 2 to enum. C is the color 2 and line. Let's try if this code is working. Yeah, assign integer to 2, assign integer to enum is equals to 2. I think this one is working properly. Okay, the next one is number 4. Oh, number 5, performing arithmetic operation. Let's try this one. So I will just perform maybe arithmetic operations first. Okay, number 5. So arithmetic operation. operations. So even though C is an enum, C++ allows it to be used like, okay, I'll just move this one a little bit, an integer. So in arithmetic operations, even though C is an enum, C++ allows it to be used like an integer. So example, for number 5, integer x is equals to C plus 1. Okay, semicolon. So C out 5 C plus 1. C plus 1 is equal to x and line. Okay, let's try to run this program. Okay, C plus 1 is equals to 3. Okay, so again, in arithmetic operation, even though C is an enum, C++ allows us to be used like an integer. Okay. Okay, what else can we add here? We have here performing arithmetic operation. Maybe we can add here the assign invalid numbers. Let me try this one. I will just do the switch later. And also we can maybe increment numbers. We will try if what happen if we increment numbers in C++. And also we have here the switching. We have here 10. What else? Okay, I will just proceed. I will just think of another one later. Okay, number 6. So my number 6 is assign invalid numbers. Am I correct? Yeah, assign invalid numbers. So assign invalid numbers. Okay. Okay, so I will explain first. So 10 is not a defined color value because we have red, blue, green. But C++ still allows it using testing. Okay, number 6, assign invalid numbers. Well, 10 in my example here, 10 is not a defined color value, but C++ still allows it using casting. Okay, let's add the code here. This is my number 6. Okay, so example C. Okay, I'll just move this one up. Okay, C is equals to color 10. So C out number 6 that assign invalid value 10. So what is the next code? Of course, C and line. Let's try to run a program for number 6, example number 6. So assign invalid value 10 is equal to 10. So it's not a color anymore. It's not a color anymore. We just input a invalid number, so it's now number 10, which is our enum is red, green, and blue, which is 0, 1, and 2. And this one we just assign an invalid value, which is number 10. Okay, so again, these are some of the examples of the different safety of enumeration types. So I have now here 6 examples. So in our activity here, we will create at least 10 different operations. It's a lot, but okay, let's continue. Number 7. What we are going to add here for number 7? Increment numbers. How can we increment numbers in C++ and test the safety of enumeration types? Okay, let's try. I will write this scenario for number 7. So this one is increment. Okay, C is equals to red. C is equals to color, and then C plus 1 semicolon, and we have here C out, 7 after increment, C, which is the color, and C plus 1 and line. Let's try to run a program. So again, this one is number 7. So after increment, it's now number 1. Why number 1? Why this one is number 1? Okay, wait, happened. Okay, I'll run the program again. Okay, why this one is number 1? I will explain. So C plus 1 means 0 plus 1, so which becomes 1, right? C plus 1 means 0 plus 1. Why 0? Because red is 0, which becomes 1. Then we cast it back into color, so C becomes green. Okay, so this is the explanation of number 7, the after increment, why the answer is 1. So it's again C plus 1 means 0 plus 1, which becomes 1. Then we cast it back into color, so C becomes green. Okay, so that's number 7. Okay, so we have 3 more. My 8 here is I will just use using switches. Maybe I will do it in the last part. Increment numbers. We don't have comparison, relational comparison. I think that's the last one. Yeah, relational comparison. I think we have now 10 examples here for checking the safety of enumeration types, different enumeration types, if this one is incorrect or silly things. Okay, so let's continue to number 8. So because it's 10, we need at least 10 operations. Okay, so number 8. My number 8, as I said, this one is a relational comparison, greater than, less than, equal to, or comparison. Okay, so scenario, green has a bigger numeric value. So again, what is green? Let's go back here. Green is 1. Okay, numeric value than red. Red is 0. So this is true. Okay, I will write the code for this statement. Okay, so this is true. Let's start here. If green is greater than red, okay, C out green is greater than red. I'll just make it green is greater than red. Okay, so the next one is and line. Let's try to run this program. This is number 8. So green is greater than red because green is 1, red is 0. Let's try this one. What if I will use the less than? What will happen to our program? So nothing happens here because it will just we will have an output if green is greater than 1. So I'll just return to the greater one. Okay, green is greater than red. Okay, we have now, I think we will come to the switch one, the switch statement. This one is quite a long code, that's why I made it last. And the last one, maybe we will just use the checking whether value is valid. Okay, or we will just maybe try to use the, we will check later if the value is valid. So number 9 here is using switch statements. So I will just write the code. Okay, so number 9 is the switch statement. So I will write a code. I will write a program using the switch statement. So switch, I will name it again C, open and close curly bracket. Let's try cased red, C out, 9 color is red. Correct. This one is and line. Maybe I'll just copy and paste some of the values here because the code they are the same. So case red. So the next one is we have here cased. Oh, I forgot the break. Sorry, I forgot the break because this one is a switch. This one is, we need a break here. Okay, case is equals to green. So color is green. And the last one here, we have here blue. C out color is blue. And line, and don't forget the break. And maybe the last one, I will just add the default one. If the answers is not here, I will just catch using a default. So C out less than, oh no, we have here invalid color, and line. Okay, let's try this one. Yeah, color is green. I think this one is the correct one now. Okay, I think this one is the correct one. Okay, so by the way, this code, I'll just add a comment here just to make a clarification for this part of the code. So this code checks the current value of C and prints the matching color. Okay, so again, this part of the code checks the current value of C and prints the matching color. Okay, so this is the number 9, and I think this is the last one for number 10. So my 10 is, I will just maybe check if whether the value is invalid. So number 10, okay, so remember red is equals to 0, and blue is 2, right? Blue is 2. So let's try to check this one. Integer y is equal to red or blue. C out number 10 is red or blue is equal to y, which is integer y, and L. Okay, and let's return to 0. So let's try to run this program. I think this one is why we have 2 curly brackets here. Oh, here, supposedly here. Okay, let's try this one out. Yeah, I think this is the correct one. So red or blue is equals to number 2. So this is the example of a C++. So in C++, the enum can easily behave like an integer. It allows printing the numeric value, doing arithmetic, and even assigning invalid values such as 10 through casting. This shows that C++ enums are flexible, but they are also less safe. So that is for the C++. Okay, so we are done with the C++. So let's proceed to C# now. So I will just create the same operations that we use here, like the printing enum values, comparing enum values, assigning, and so on. Okay, I will create a new online GDB here. Okay, language now is, I will just use the C#. Okay, I will run this one out. Okay, I will clear everything. I might copy some of the codes from the C++ here. Okay, so let's start with the C#. So we are done with the C++. Now it's the C#. So let's start with this code. So using system. Okay, so I will just copy the code from here, enum color. Okay, let's try to run this one out. Okay. So in C#, instead of using the integer main, I will use the class program. So class program, okay, static void main. Okay, same process. We will just add the color. C is equals to color that red. Okay, so number 1, again, print enum value. So again, for number 1, we will print the enum value. So this is 1. Console that right line 1, value of C is equal to plus C. Okay, let's try this one out. Okay, compilation failed, errors 1, console at right line, color C, static void main colors, color C red, console, the right one balance. Okay, I will just continue first so that we will know some of the problems here. Okay, so number 2, compare the enum value. So I'll just write here print compare print enum value. This one is compare enum values. Okay, so this one is if C is equals to color that red, console that right line to C is red. Yeah, let's try this one out. Okay, so later if we have some problems we can check it here, but so far I think we don't have major problems. Okay, number 3. So in number 3, I will just change the enum value. Okay, number 3. Example here, we have C is equals to, instead of color red, I will use the green one. And then I will write here console that right line. Number 3 is C change to plus C. Okay, let's try again if we have some major problems. Okay, let's continue to number 4. Again, this one, the concept is the same with C++, because the activity here is I will just rewrite the program using C#. That's the same thing around to determine how many of the incorrect or silly things are legal. Number 4, I will just cast enum to integer. Okay, number 4, integer num is equals to integer c. Let's try. So console that write line for that enum as integer plus name is num. Okay, let's run if we have major problems here. Okay, we don't have major problems here. Okay, number 5, we just cast the enum to integer. So number 5, I will cast again integer to enum. This one now is we're going to switch it. Number 5, cast integer to enum. So c is equals to color 2. Same code with the C++ here. So c is equals to color 2 console that write line. So my number 5 is assign integer to 2, okay, plus c. Let's try again. Okay, we don't have major problems. Okay, number 6. So in my number 6, I will assign invalid value. Okay, number 6. I will just use the same concept here for number 6, assigning invalid numbers. Let's go back here. Number 6. So in number 6, 10 is not a defined color value, but C# allows it with explicit. Just make this one. Okay, I'll just where am I now? Explicit casting. Okay, so 10 is not a defined color value, but C# allows it with explicit casting. So number 6. Okay, number 6. C is equals to color. Okay, not this color. Color 10. So yeah. Okay, so console that write line 6 assign value 10 plus C. Okay, semicolon. Oh, I forgot forgot the semicolons here. Let's add this one, I think. Okay, let's see. Okay. Oh, yeah, I forgot. Sorry, I forgot the colons. Anyway, so I think that's a problem earlier. I never imagined it that I forget the semicolon. So number 1 is value of C is red. Okay, I will just and number 2, C is red. Number 3, color change to green, from red to green. Number 4 enum as integer, so enum as integer, which is 1. Number 5, assign integer to 2, which is blue here. And number 6, assign value to 10. Okay. I'll try again. Okay. I think that's the problem. Okay, let's add here. Add some spaces. Okay, number 7. So in number 7, we will do again the arithmetic. Integer x is equals to integer c plus 1. So it is the same concept with the number 5 here. This is number 5. Okay. Number 6, integer x is equals to integer c plus 1. So I will just console that right line. 7 c plus 1 is equal to plus x. Okay, let's try to run this. Oh, we have some errors. Again, the semicolon as always. Okay, c plus 1 is 11. Why 11? Number 6 here, we have the value of 10, and then we added with 1 plus 1. That's why it's 11. So again, as I said, it's the same concept here. Okay. Okay, so I'm now in number 7. Okay, 3 more, because in our activity, again, as I said earlier, we need at least 10 different operations. Number 8. So number 8, increment. Before I forget, this one is the increment. Number 8. Let's do it again. So c is equals to color dot red. Okay, I'll just c is equals to color integer c plus 1. Okay. Let's double check the code. C color integer, I forgot one parenthesis here, c plus 1. Okay, space here. Okay, c plus 1. Okay, so next is I will write again the console, that right line. Number 8 is after increment plus c. Let's try. Yep, after increment it's green. So I will explain more. So I'll explain more here for number 8. Okay, for number 8, we will convert red to integer, add 1, then convert back to color. Okay, so this makes C become green. So that is the explanation of number 8. Okay, so number 9, number 9, so we will do the switch for number 9. So I will do it again, same syntax for the switch. So we will start with switch. I will name this one as C. Open and close, open and close curly bracket. I'll just make this one up. Okay, so switch C, this one is, we have here a case of color red. That red. And then we will console, we will show the output, right line, 9, color is red. Before I forget, semicolon, let's do the break. Let's try. Okay, I'll just continue this one first, some of the cases. Good. Blue. Default. Nine in valid color. Let's break this one out. Okay, let's try again. If we have some problems here, we had problems on, okay, symbol expecting. Switch C. Try to run the program. Okay, so I have some errors here. Okay, so color. Oh, sorry. This one is a switch. So this one is a column. Okay, let's try again. Okay, we have here number 65. Okay, I have some errors here. Let's color that red, console that right line, break, case color that green, console that right line, and color green, break, case color blue, break. I will finish this one first so that we can determine which one is the problem. So again, the number 10 is, we will just check if whether the value is invalid. I will finish this one first and then we will do the debugging again. If we have some problems, we can fix it easier. Okay, so number 10 is check if value is defined or valid. Oh, that's valid. Okay, so console that right line, 10 is value valid. There's a question mark, plus enum that is define type of color. Okay. This one is open. I will just move this one a little bit, color, so that I can see the code. C. Is it correct? Okay, I will try again. Okay, we have two errors here. End of file number 83. Okay, let's try again if we have some problems again. So we have here a problem expecting. Okay, let's run the code again. Number 65. Where is number 65? Okay, this one is correct. Break. Oh, okay, found it. Break for default. Let's try again. Okay, we have here also problems with end of file for number 83. Okay, console.write line and define type color C. Okay, I will save this one first. Okay, I will run the code again. Okay, and number 83. Still we have a problem. Okay, maybe this is the problem. I will just reload this one because I think the problem is the platform itself. So I will just upload the file again. Okay. Oh, okay. This one, let's try again. Okay, that is the correct one. So I just missed one of the curly brackets because of the platform. Okay, so in C#, we just I just write a code for print, compare, change, cast enum, cast integer to enum, assign invalid values, arithmetic, increment, switch, as well as check if value is defined or valid. So in C#, enums are controlled. They are more strongly typed, which means the language is stricter than the C++. So it is stricter when using them. For example, in arithmetic operation, it requires explicit casting. However, in C# still allows invalid values if we force them through casting. So for the summary, based on this activity, we can say that C++ and enums are less safe, while the C# enums are safer but not completely protected. Okay, so In my conclusion, both languages allow some incorrect or silly enum operation, but C# provides better types in terms of safety than C++. So I think this is my activity for laboratory exercise 005 for this procedure, which investigates the safety of different enumeration types, both C++ and C#. I think I answered the question, what is the output of the program, and also compare those results. And this video includes some of the discussion of the source code. So as I said earlier, this activity shows that C++ enums are less strict because they can act like integers more easily. C# enums are safer because many operations need explicit casting. However, as I said earlier, both languages still allow invalid enum values in some cases. So overall, C# is safer than C++ when using enums. So that's all. Thank you, Professor, and have a nice day.